Okay, so we start with examples, and this is the first one. Now, what is key to understand here is that um, we are dealing with change. And so we always have to remember that what we're dealing with is change. Okay, so changing this function here, changing the function because of changing inputs. So that's what basically derivatives are. So we have f(x) like this. Remember the formula. And so here we have dy dx, it's the same. And then it's going to give us what? It's going to give us limit, because we're saying it's a limit definition. And then the change, we're talking about the change here, not the x. Okay, the change, not the x variable. And then we are going to say that the change in the x variable inputted into the function minus the original function. And then we can talk about change in x there. Would have found the derivative. Okay, so let's go on and now we can put the expressions here and see what happens. We can do them separately, or we can combine everything together and find the solution. Okay, so the moment we take this and apply it, then we can begin. So here we're going to say the first part. And remember, we actually did something like this. Like, for example, if you have the equation like this, the function like that, if I changed this and I put x plus 2, this changes to 5x plus 2, right? So this new equation becomes 5x plus 10, new function. It's the same here. We are going to first look at the input x plus h. So we'll have half. Okay, now the x has changed to x plus h, right? Minus 3/5. And then we are saying that we should subtract the original function, which is half x minus 3/5. Right? And then we have h here. H remains. So then we can go on and expand. Here we're going to have half x plus half h minus 3/5. Okay, then we continue here. We're going to have half x. And what will be there? That'll be plus 3/5, like that. Then we still divide by h. So what happens here? We can see that like terms will cancel out because they've got the same value. Which are the terms? This one and that one. Then what remains is half h over h. Right? So we can still proceed and cancel these two to get us half. So what are we saying? We're saying that the derivative of this function here is half. It's not the value of that function. It's just the derivative of this function. So it's constant. Okay. So we can even say that dy over dx is equal to half. It's always nicer to represent it like this because you're saying that the change everywhere is going to be the same. And so the representation of this shows you that actually this is what, if you put it on a thing, on the x or y plane, it'll be a straight line, meaning that the change is the same. If you check the change here, it's half. Check the change there, it's half. Check the change here, it's half. Check the change there, it's half. And that is why you're able to find this. But if it was like a quadratic equation, the change here, the slope here will not be the same everywhere. Okay, it will not be the same everywhere. So you'll see once we do this that it will not give you half. It will probably give you something with a variable like that. Okay, but for now we're saying that the derivative of this one here is actually half. All right, let's check another example.